Hello. Yeah, hello, good afternoon, everyone. My name is Mohammed Amjad Basha. So I'm working as a technical specialist for engineering solutions. So basically, I'm a mining engineer. Did my BTech in mining engineering from Kottagudem School of Mines and worked in various mining companies like Vedanta Aluminium Limited, Tata Consulting Engineers, and currently I'm associated with EDS Technologies Private Limited. So today I'll be explaining about give a brief introduction of these application of mine planning software using the SAPAC software. So before going into the presentation, I'll just give a glimpse of my company. So our company is EDS Technologies. We have a mission called to provide high quality PLM, that is product lifecycle management and visual simulation solutions, and delivering the value to the customers by taking their ownership of the projects and then delivering high quality results in a timely and cost efficient manner. So this is where we stand. And these are the different, we are having different offices across India. So like 16 locations in India, and with 200 plus associates and with 1500 plus customers. And we are in India since past 2 decades. And we are having these business solutions. So these are the industries which we target, like for PLM solutions, we target for automotive industries and then aerospace. And for enterprise solutions for all the industries, and then visual simulations we have for defense industries. And for mining solutions, we have different products under Geovia brand. And apart from that, we are having engineering services also, which comes under CAD, CAM, CA implementation, and also the SAP or Innovia. And these are our strategic partners, which we do the sales and then give support. So Dassault Systems, SAP, and Presagis, Netlink. So these are our major partners. So coming to the presentation. So normally everyone knows that mining is the process of extracting a naturally occurring mineral from the earth to derive a profit. So profit is the major concern for mining. So we confine our discussion of mining to the extraction of the following minerals. So due to the time constraint, I'll just explain about the software regarding the metallic ores. So that is bulk deposits or any other vein type of deposits. So these, we know that ancient mine was in England, which was exploited about, like for example, say 3000 to 1900 BC to recover flint. So that's the first mine, and that too is underground mine. And while mining, we have 5 stages. So one is prospecting, so to see whether any mineral is there below the subsurface or not. And then after we know that the mineral exists here, then we do the exploration. So after exploration, we go for the development, that is to start the mining activity, and then exploitation, that is doing the production of our minerals. And then the final step is the reclamation. So these are the different mining stages we have, and this software will be applied after exploration. So once exploration has been done, so for development, exploitation, and reclamation, so these softwares, these mining softwares of Geovia can be applied. So normally, so these are the theoretical. So you as a college professors, you know these stages. So normally this software is used for entire mining life cycle, starting from your exploration to the reclamation. And for mining mine planning solutions, we have different solutions under Geovia brand. So this brand previously known as the Gemcom software. So once it was acquired by Dassault Systems in 2012, so the brand name has renamed to Geovia, but the product remains same. So under Geovia, we have products like SAPAC, so which is used for non-stratified deposits, and we have Minex software, which is used for stratified deposits. So both are the general mine planning package, which is used for resource modeling as well as your mine designing and planning. And we have a Vital software to do the financial analysis of a mining project. So nowadays, coal block auctions has been cancelled and various projects coming down. So before starting the project, you know to evaluate whether we can go for the project or not. So this give the financial analysis, and this will do the feasibility studies. So in college, maybe you are doing the feasibility studies of a few mines. So during that, Vittel software may be helpful for you. And the Mindshed is the software which does the scheduling for long-term or short-term scheduling. So based on the requirement of the mines, so you can schedule and then you can implement these schedules into the real-time scenario. And we have Insight, so it collates the progress of production activities against the plan. Means what you have planned, that means what you have scheduled and what you have achieved. So what's the difference between them, and where the problem is coming, so where you have to improve in order to overcome those problems or overcome those errors. So, and coming to the application of these different softwares, so Subpack, Mindshed, and Vittel, as told, are used for metal and other than coal modeling software, especially in India, because for bauxite and limestone also in India, customers are using Subpack software because bauxite and limestone in India are not true stratified deposits. And for true stratified deposits like coal in India, we are using Minex software, and Vittel is for pit optimization, and it is limited to the open cast mining only. Whereas Serpac and Minex are used for both open cast mining and then underground mining. And Mineshed is for production and scheduling of open cast mines as well as your underground mines. So you can do the scheduling of any other open cast or underground. And we have Hub for secure remote data management. So this is like SAP of mining industry. And Insight for production management. And these are the different fields where these softwares can be applied, where one is your surveying. So the basic requirement of any industry, that before starting production or before going for exploration, so you start with the surveying. You have to know the location where you are drilling, you have to know the location where you are mining. So and you have to calculate the volume, how much you have mined or how much you have dumped. So for that case, surveying application is required. So apart from surveying, software can also be applied in geological resource modeling. So once exploration has been done, you have to determine your ore body, and you have to estimate your resources, how much resources are available below the subsurface, so that you can mine those resources profitably. And the reserve estimation, so once ore body modeling has been done, you have to estimate your reserves and do the mine designing. So mine designing means how you have to excavate or how you have to extract those minerals below the surface. And dump designing, so once you have extracted the minerals, so you, apart from that, you will be extracting the waste also. So you have to dump some in your mining lease area only. So for that case, you have to design your dump area, and then you have to see whether those waste material will be accommodated in it or not. And then coming to the mine scheduling, so you have to schedule your mines before going for day-to-day planning or for weekly planning. So for that, mine scheduling will be required, and pit optimization to do the financial analysis of a mine. And these are the various customers in India, particularly for academic institutions. Like ITBHU is having SAPAC and Vittel softwares, and IIT Kharagpur, ISM is having SAPAC, Minex, and Vittel. And BESC, it's in Shibpur, Kolkata, and the College of Technology and Engineering, Udaipur, Department of Geology, Goa University, and Nagpur is also having VNIT, and NIT at Surat, Rourkela. And apart from these, recently NIT Raipur has purchased both SAPAC and Minex software, and we have given training to them in two separate batches. So two batches have been trained by us in college itself, and they are planning to buy a few more licenses so that each student can use software independently. And coming to the SERPAC, why SERPAC is so much important in our mining industry. So SERPAC is the most widely used software system of its kind in the world, because it supports both open pit and underground mining operations, and also the exploration projects in more than 120 countries apart from India. And SERPAC enables mining practitioners like ourselves, like educational institutions, and then mining companies, to quantify and evaluate the mineral deposits. So especially SERPAC is for non-stratified, and to plan the efficient extraction of those reserves. So if you cannot efficiently extract those results, then there is no value when if you are extracting like like a mining or sign mining. So it has to be efficiently extracted. And these are the few benefits apart from the other softwares which are having in mining industry. So Surpac reduces data duplication and interfaces with common file formats like with geoscience applications. So in college you will be having maybe GIS or map info. So you can use those data into the Surpac and then work on that. And then you can import your survey data and generation of a 3D surface. So if once you have surveyed your entire topography or entire mine, so we can import that survey data and create a 3D surface to calculate the volumes or to generate the contours. And easy and instantaneous generation of different type of contour plans, geological data management, and geological section preparation. So this is very much useful for ore body modeling. And then resource modeling and estimation by various methods. So normally we have various methods for estimation of these resources, and it's a very user-friendly software. So you can learn. We give a training of 5 days, and then you can start working on that. So it's a very user-friendly. So commands and windows and everything, and it's a modular and easily customized. So based on the requirement, modules can be purchased and it can be customized as per the customer needs. So these are the different modules we have in Surpac. One is the standard features, which will be useful for displaying your data in a 3D modeling environment, and then do the plotting or create or work with any point or line data. So if you want to import your AutoCAD data, so you can import those, and then create a 3D surface of a line or point data, and then you can also do the scripting. So if students or if yourself are well versed with C++, so you can create a scripting and then you can reduce the steps to be done for a particular work. And in optional modules, we have tools like auto plotting, data plugins. And in geology, we are having a geological drill hole database. Once exploration has been done, you can create a database from that exploration data, and you can do the basic statistics. So you have to evaluate how the exploration has been done, what data can be useful, and what is the statistics of your data. So to all these, you can do the basic statistics and also the geostatistics to analyze the trend of your ore body. So in which direction your ore body is continuous, or how your ore body is behaving, how you can estimate your ore body based on that. So and then you can do the solid modeling, that you can create a 3D ore body model using the solid modeling, and then block modeling, which will be useful for estimation of your resources. And we have dynamic shells and then mesh tools, so these may be useful during the exploration. And coming to the engineering, we have pit and dump design, where you can design your pit and as well as a dump. And road design, which is for X-pit haul road. So if for in-pit haul road, you can create or design those in-pit haul roads with pit and dump design modules. And if you want to design your roads outside the pit or outside the dump in a topography, you can use the road design module. And then drill and blast design, so where you can design, charge, and report your surface blast hole patterns, and then you can see if you are drilling in the particular area, how much volume can be extracted. So all these data can be extracted from the drill and blast design. And the stope design tools and underground ring design are especially for underground mine designing operations. And in survey, we have surface and underground surveying, which will be useful if you are if you want to connect your survey stations or any other DGPS equipment to the directly to Surpac, direct to the system, and then you can access the data in Surpac itself. And this is the application of Surpac software, especially in surveying. You can directly download or upload your survey data through any of your total stations or any DGPS instruments. So recently we have released new versions, so which handles the drone survey data also. So drone survey is like a big data management. So now we have improved our software so much that it can handle that much of big data generated from the drone survey. And the input via total station or any of the GPS instruments will produce a 3-dimensional ready-to-plot plans, and also you can produce contours or sections from that 3-dimensional data. And then it is very easy and accurate estimation of volume for pre and post excavation. So if you are mining, so you can see how much, what is the difference between last month and this month excavation has been done. So this is very easy for calculating this volumes. And this is an example of a plotting. So once you have a survey of mine and then you have imported the data into the survey, you can take a plot plans. And this is an example of a plot plan which has been created in survey. And these are the sections, so you can extract the various sections. So it may be horizontal sections or vertical sections or any oblique sections. So you can extract your sections from your survey data in any direction, and as well as you can generate your contour plan. So there is no such requirement that you can generate in 0.5 interval, yeah, 1 interval. So you can generate your contours in any interval as per your requirement. And this is an example of a screenshot where volume has been calculated from 2 DTM surfaces. So here DTM is nothing but digital terrain model. We call surface as a DTM surface. And this is the other example of a cut and fill volume report. And coming to the geology, the application of SOPEX software, especially in geology, is to create your borehole database from the exploration data. And once the borehole database has been created, you can visualize those boreholes in a 3D graphics window. And you can take create a borehole logs from the database and create a geological plans and the sections. So once the geological sections has been created, so you have determined how your ore body is behaving. So you can wireframe those and create a ore body model based on the geology or based on your grade. So you can write from your ore body based on both lithology or a grade also. And then you can do the block modeling to estimate your grade by various interpolation methods. We have like inverse square distance, ordinary kriging, and simple kriging are various interpolation methods. And you can compute your geological and mineable reserves at different cutoff level. And the block model refinement. So once the block model has been created, so you can refine your block model during the mining operation. So this will be useful one. So this block model refinement mainly does in the mining industry. We are currently mining the resources. And this is an example, like left side you can see the raw data of exploration data, and in right side you'll see the data managed into a CSV format so that it can be imported in SURPAC. So once it's imported in SURPAC, so you can utilize your boreholes both in a 3D graphics window or in a plan view also. And these boreholes are colored based on the color coding of a lithology. And these are the examples of geological cross sections. So once geological cross sections have been created for all the boreholes, so you can create a 3D ore body model. So this is how your ore body will be having. This is an example of your ore body below the subsurface of a particular project. So this is how you can visualize your ore body. And then this is an example of a block model. So once ore body has been created, you can divide all those blocks into mining blocks, and then you can estimate those resources. And then these blocks are colored based on the Fe grade of a deposit. And then these are the various estimation methods. So one is inverse distance, ordinary kriging, simple kriging, nearest number. And apart from that, we have geostatistics library estimation methods also. And this is an output of a resource or reserve reporting. So once you have estimated your resources, you can do the reporting of those resources or reserves. And you can extract the slice plans of a block model. That means at a particular RL, what are the kinds of ore, what are the grades you are available to extract. So that's how a slice plan can be created from the block model. And once your resource model has been estimated, you can do the pit designing. So based on the requirement of regulatory authorities like IBM or DGMS, so you can design your pit. And this pit can be designed with different slopes in different areas. So we may be having different geological zones. So based on the geological zones, so we can have different slopes in different areas. And it means within the pit we can design a ramp, circular as well as all cut ramps, and this pit can be limited to the ore zone only, so as to avoid wasteful mining. And this is an example of an open pit design. So once you have digitized, created your pit and then created a surface, so this is how you can look your pit. And this is the pit designed in a hilly area, so where you find the benches in one side only, but in valley side you will not find any benches. So this is how mining of a hilly area can be done. And once pit design has been completed, then you have to design your dump design, because you have to accommodate your waste material. So you can select the location for dump designing, and then you can generate strings, and then from that you can design a 3D surface of a dump, and then you calculate the volume and see whether that particular dump will accommodate all those waste excavated from the pit or not. So if it's not excavated, then you have to select another area, and then you have to design another dump. And these are the plot plans of a slice plan from the block model. And this is an example of a drill hole plotting. So once a database has been created, you can go for the drill hole log creation. So where you can see the depth of the borehole and types of lithology available, and what are the ore types, and what is the grade available, and what is the sample length in that borehole. And these are the different section plots. And coming to the benefits of Geovia, particularly in academic license program. So it includes industry standard technology in the curriculum, and training and support on the software usages. So when you have purchased the software, so it's not like you have purchased and then we left. So we will give the training, and then we will give the support on the software usages, and we will guide your students. So if any student is interested to do their project using the software, using the Geovia software, so we will support them, and then we will assist them to complete their project. And we also provide students the technical skills they need to enter the workforce. So before joining any mining industry, so if they need any technical skills based on the software, so we are very much happy to assist them, and enable students to find work faster by gaining valuable experience with the industry's widely used software. So as you know, so SEPAC is widely used software in India and in entire world. So it's a very widely used software. So you can learn the software, and then you can add the value. So once the industry knows that a student knows the mining software like a SEPAC, then it adds a value to them. And we have economic discounted price, which suits for the academic institutions. So it's not like we have different prices for commercial and then academic. So we give huge discounts for the academic institutions. Yeah, thank you so much. And if any queries are there, please let me know. And if you want to write a mail, so this is my email ID. You can write a mail to this email ID, and then we will revert back to you. Yeah. Thank you all.